for question 4. Okay, let's get started for question 14. So which method would give this? Now this is kind of a weird structure, so I'm going to draw it out for you. Okay, we've got that carbon. It has an OH. It has two CH3s. Right here, CH3. Sorry, I'm having to go above because there's just not a lot of room on this. That's a CH3. And then it has this carbon-carbon triple bond. And the reason we draw carbon-carbon triple bonds as a straight line instead of a bend like you're used to is because they literally are straight. You know, it's like sp3 hybrid or sp hybridized, so it's 180 degrees. Whereas, you know, we have tetrahedral for some other things, so that's why we do up and down. So that's why we draw it as a straight line like that. But there are two carbons on either side of it. Okay, so that's our final goal. So which method would do that? Okay, well, I think the chromic acid would first oxidize. That's an oxidizing agent. So it would take our, if you want to see this secondary alcohol, to a ketone. It could not go to a carboxylic acid because secondary alcohols can't do that. Remember, if you have a primary alcohol, it will go first to a aldehyde and then to a carboxylic acid. If you have a secondary, there's no other bonds to carbon or hydrogen that you can flip to a bond to oxygen, so it just stays there. And if it's tertiary, there's nothing you can do. No reaction happens at all. So secondary will go to a ketone, and then we have this as our nucleophile. So it will attack and kick up. This is looking promising, actually. O minus, and then the carbon-carbon triple bond right there where it added. There's not a good leaving group, so there's nothing that would like come back down or anything. So we would finish off with adding acid. So this actually could be one of our answers. I don't know if there's multiple, but at least that is looking good. So none of these choices we can go ahead and get rid of. Next, we have copper lithium. That would add like this. But then this is an oxidizing agent, so I'm not really sure what that would do. I mean, first you get the O minus and then the acid gets the OH, but I don't really know because it's a tertiary, so it couldn't oxidize. So I think that is not going to be an answer. Let's answer choice B. C has your carbon-carbon triple bond already here, and then it has a Grignard reagent. And this Grignard reagent, there's two equivalents of it. So one is going to steal that proton, remember, because Grignard reagents will react with an acidic proton 25 pKa or more acidic. So 25 pKa or a smaller number. So it'll react with a carbon-carbon triple bond, a hydrogen off of an alkyne like this. It'll react with an alcohol. It'll react with water, anything like that. So this will actually happen, but there's two equivalents, so then it can still attack. So your actual structure will look like this. Your CH3 where it attacked, and then your carbon-carbon triple bond, and it'll have a little minus charge there. This is from up top. So it looks like this. And then you could just add acid to that, and you'll actually get the structure that we're looking for. Great. So it looks like answer choice A and C will both work, so D would be your right answer. All right, let's go to number 15. Okay, now remember that chart that we drew. You've got carboxylic acids, esters, ketones, and aldehydes. These, NABH4, will reduce only these two. LAH will reduce all of these. So, we've got an ester and LAH. Ester, LAH, that works. NABH4 with an aldehyde, that works. H2 with platinum, maybe with high pressure, but I'm going to think that probably won't work, and that's probably our answer. And then D, NaBH4 with a ketone, that works. So I always draw that out, so I think answer choice C is our right one. You could maybe force this if you had really high pressure, but I don't think I've seen that, so I think this would be your right answer. Okay, question 16. What is the major product from the reaction of toluene with KMNO4? Okay, so here's a little tip for you. Toluene with KMNO4 is always going to turn it into a carboxylic acid. It's like this weird thing where it just like boom chops off, and I call it chopping off a chain of spaghetti. So you could have any chain there and it will chop it off and turn it into carboxylic acid. That's benzoic acid. So your right answer for that one is answer choice B. Okay, and then question 17. What is the principal product formed when 1 mole of a Grignard reagent reacts with para-hydroxyacetophenone? So I guess you don't need to know this nomenclature yet. We'll get more into that in a later chapter, but this is the structure, para-hydroxyacetophenone. So we just talked about Grignard reagents, with this pKa being 15 to 17, or I guess it could be 16 to 18 as an alcohol, that's going to be more acidic than your alkyne. So I guess acidic as an alkyne or more so, which means that the first thing that this is going to do, if there's 1 mole, so 1 equivalent, is make this. Now, we just saw in the other experiment, if you have 2 moles of this, then your reaction will take place, but this is 1 mole. So your right answer, the CH3, is just basically, I like to draw it like this and get rid of that. Will just come and attack. So you've got your O- with a nice counter ion and your CH4. Okay, and then for question 18, what would be the product of the following reaction? So this is just a handy reaction to know. If you have a primary, secondary, I think even a tertiary, but don't quote me for sure on that one, but definitely primary or secondary. PBr3 will turn it into a bromine. SOCl2 will turn it into a chlorine. That's often used in Grignard reagents. So first you get your chlorine or your bromine in this case, and then you add your magnesium and it becomes a Grignard reagent. And I just, like I said, I turn my Grignard into this. And then we have, excuse me, D2O. So D2O is just like water. It's heavy water. So another way you can think of it is just like labeled hydrogen. So it's basically like, oh, here's a hydrogen with a star by it, or here's a hydrogen in blue. It's so that you know the process of this reaction. So this will take, just like it would from water, your Grignard reagent reacts with anything more acidic than an alkyne. So this is another example of that. And you'd have D plus OD minus. So your right answer choice for that one would be, sorry, I kind of have to do a weird angle here for the camera. Is that answer choice B? It looks like. So that's basically just testing if you know how Grignard reagents react with water, and that D2O is like a labeled water. Question 19, predict the product of the following reaction. So LAH will reduce a ketone. You can, if you want, draw the mechanism. So you'd get O minus, the CH3 is already there, and then your H here. And then you add acid to make it OH, CH3. Now, I don't think that this would change because everything's happening on the adjacent carbon, so this should still be the same stereocenter. So I think they just kind of did that to mess with you. But this would be a racemic mixture, so it's asking which one of these would be correct. I think this could be a racemic mixture. So because this could be the racemic mixture, I would say This right here could have two types of stereochemistry. The CH3 being a wedge and the H being a dash, and it's an enantiomer. CH3 and H. This carbon, however, that started out as an enantiomer shouldn't change. Sorry, that's terrible handwriting, but this should stay the same. So let's eliminate anywhere these change. And so then that leaves us with, we have our alcohol here and our, for both of these, and the CH3 is racemic mixture, so answer choices 1 and 3 would both be correct. Okay, and last but not least, question 20. So which of these reactions will not produce a primary alcohol? In this one, there's not much for it. You just got to work through every single question. So this is an aldehyde with LAH. Sorry, that's bad handwriting. We've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Looks like an aldehyde with LAH. That actually should go to a primary alcohol. Oh, it's will not. Which one will not produce? So A should work. Now let's do, you don't even need to draw out this whole chain. You can just do R, because it's RMGBR, and then because the alcohol will be concentrated on the epoxide side. So this will attack and open this out, and you'll have R bonded to your epoxide, and then O minus. And that's a minus, not a CH3. O minus. And then that would get acid put into it, so that would also do it. Ooh, here we go. Okay, NaBH4 with a ketone, it can reduce this, but it cannot go down to a primary alcohol. It has to be a secondary from a ketone. So I think this is probably our answer. Let's make sure. This is going to definitely work out. You've got formaldehyde with an R group with a lithium, so it's basically R minus, just like a Grignard. So it'd be O minus, and then you'd add the acid to get OH. So that's your R group. That's definitely going to work. So D works, and E is a carboxylic acid. And so we talked about how a primary alcohol goes to an aldehyde, goes to a carboxylic acid. So then the reverse is also true. So if you have a carboxylic acid, it will stop at a primary alcohol. So your answer choice is C. Okay, guys, well, I hope that video helped, and thanks so much for checking it out. I hope you guys do well on your test, and good luck studying.